Okay, I'm giving you 3 questions to start the hour, which are kind of like things we would ask you on a test on this topic. So that top one, I've got a little hint in the circle that you better not just break it up into root 9 and root 8, because you wouldn't have broken up all the way. All right, so I'm going to give you a little bit of time to work on that, and I'm going to pause now. And so let's see who did figure out how this worked. It's square root of 9 and the square root of 8, kind of. But the square root of 8 could be broken into the square root of 2 and the square root of 4. That would mean that's 3, that's 2, and that's 6 root 2. Uh-oh, I forgot something. I'm really close. Can I say negative? No. There was a third thing in there, and it was the square root of -1. And that's what? I. All right. So 6i root 2. How many of you knew that? You had 6i root 2. Okay, good. Gentlemen, talk about it later. All right. So this 24 now has to be factored with the 6. Does 6 and 24 have a common factor? Yeah, 6. So what I hope you could have done anyway, you could have said that 24 is really 6 times 4, and then you'll see it really clear. There's a 6 in each of them. The 6 comes out, yeah, 4 plus minus I root 2. If you didn't factor the 24 into 6 times 4, you'd just have to do that in your head then. When you took the 6 out, 6 times what makes 24? Okay, and then that's all over 8. This didn't work so nice. Now I can't cancel anything. Oh, yeah, I can. What can I do to make stuff cancel? If you can factor it, you should. So I factor the 6 into what? 2 times 3. You factor the 8 into what? 2 times 4. And then, finally, I got something to cancel. There's my final answer. 3 times the quantity. 4 plus and minus I root 2 all over 4. Yes? So you multiply it back out again. 12 plus minus 3i root 2 all over 4. Yes. But I do have a favorite saying, if you can factor it, you should. And honestly, if something's already factored like that, leave it factored. Because sometimes later in the problem, something will cancel with it. I'm telling you, I've seen it so many times. Leave things factored if you can. I know it's the very end of the problem, so we didn't really need it to be factored anymore. But okay, that was a tough one. How about the I to the 17th? Would you agree a bunch of I squareds would help you to figure out what it's equal to? I squared times, and you just keep writing them, except it would take a long time. I'm going to do something smart. Did anybody do this where you did I squared to the 8th? I don't know, I just want to see if anybody thought about that. Ooh, 1 person, 2 people thought about that. Good job. Because do you get that that means I to the 16th? Whole bunch of I squareds, right? Then, is that enough to make I to the 17th? Nope, 1 more I. Final answer, -1 to the 4th is +1 I. It just equals I. How many of you had I? Just I. Okay, good. And the last one, I to the 3rd minus I squared. This part's easy. What's I squared? -1. Negative of -1 means +1. So can I just simplify it and say I to the 3rd plus 1? Nope. Because I to the 3rd can simplify it down further. That's really I squared times I, which makes what? -1I. Now, if you put this, I'd cry a little bit and say, oh, they were so close. Who knows a smarter right answer? Yes? 1 minus I. Why do you have to put the whole number first? Because the real part is, I shouldn't say whole number, the real number first. That's supposed to be first. And the second part, that's supposed to have the imaginary stuff in it. Okay. This stuff, I don't know, I feel like this stuff is easy, but I also know kids make mistakes on it. So I don't want to be lulled into thinking that everybody just rocked that thing. If you had to predict which one you think the class got wrong the most? Which one do you think that people got wrong the most? 1, 2, or 3? All right, I'm going to give you one more like number 1 then. 12 plus and minus the square root of negative 50 all over 6. Wait, I'm wrong. Wait a minute. Nothing would factor out of that. Sorry, 15. We're going to start with 15, not 12. There we go, 15, and then all over 5. There. You know that feedback thing where it goes weep, it gets really loud? Do you guys actually know what's happening there? It's hearing itself. Yeah. So it hears that there's a noise that was happened. And did you know that it's actually happening right now? It's just you can't hear it. It's so quiet. It can hear itself, but the sounds that it hears are so quiet that even when it amplifies it, you still can't hear it. Anyway, but if you get close, if you get a mic close to that speaker, it'll go faster and faster and louder and louder and louder and louder, and it just gets like, ooh, it can hurt. All right. I learned something interesting the other day. You can actually hear a sound loud enough to kill you. Whoa. That's a weird concept to me. All right, so this. Start there. Dice of Destiny, who should I call on? Row 6, 5th person. That's you in the back. Oh, that's perfect. Picture perfect. Now I'll go a little further. I'm not sure you mean 25. Do you mean square root of 25? So 5i square root of 2. Good. There we go. Raise your hand if you got that far. Awesome. I'll jump a little bit here and ask next person, row 1, person 4. That cycles back to it's you again. Okay. What did you get for the factoring out the top part? 15 plus minus 5i root 2. What does that factor to? 5 comes out, because 5 times 3 is here, and that's just 5 times 1. Do you have to do that little step? No, but if you have trouble factoring, I think it would help. All of you could make little multiply problems. Then when you pull out the 5s, you see how you know what's left? 1i, which is the same as I root 2. All over 5. 5s cancel. There's your final answer. 3 plus and minus I root 2. Raise your hand if you had that one right. Awesome. Okay, we're getting closer. So the test is tomorrow. What's left? Well, let's find the file that has been posted. Sorry, not tomorrow. Not tomorrow. There's one more thing I have to teach you, and then tomorrow's the review, and the test is Friday. Sorry. All right, so find that file that's been posted for today. Raise your hand if you were able to find this file so I can see how many people are with me. All right. If you haven't, find it soon. It's under today's date, which is 10-24. Okay. So what do we have to learn how to do now? Solve using complex numbers. What do you mean solve? Well, solve like this. And what's different about it than we've done before? As soon as you subtract 4, you'll figure out that something's different than normal. Because right here, you would normally have taken a square root, and then, oop, you get one of those square roots of negatives. Do you remember that just a week and a half ago, I would have just said, oh, no solution. But now it's like, oh, you just keep going, right? Go ahead, keep going. Solve this thing. Square root. This side, hope you've learned by now. That's a nice simple. What's that one? Miss S? 2i. and this side, square root of x squared, it's actually not that simple. People think it is. They think it's just x, but hopefully you know better. What is it? Okay, hold on. Absolute value of x, which will then lead to the whole plus minus thing. But you need to know this. This means absolute value. If you graph this, it says this, it is the absolute value. It's not plus minus anything. It's absolute value. Now that's going to lead us later to have plus and minus in my answers. This is hard to learn. I still remember a math teacher sitting down with me when I was a new teacher here and saying, okay, you've got to get this straight. This is really important. The square root of x squared is not x. And it's not plus minus the 2i. That's not what's really happening. You have to understand the definition of absolute value to get this. And believe it or not, weirdly, I'm on the same page in pre-calc today. They're relearning the same thing in pre-calc, where you're going to be a year from now. It's one of those weird days where the topic's the same in my honors higher algebra and in my pre-calc class. It's like one of the only times it ever happens. But they're relearning this and going further with it. All right, so square root of x squared is absolute value of x, which then breaks into two equations. To do this, you just take the absolute values off. X equals 2i. It is that simple. You just take off the absolute values. Then you have to do the opposite of that. The left side stays the same. Notice it wasn't x and negative x. You could have done it that way. It would actually worked. But we're going to do the right side becomes opposite of it. It's the opposite of 2i, negative 2i. And so you could have done it this way, where you could have put the negative on this side instead of that side, and it would have worked. You'll learn more about that when you get to the higher level. Okay, so then here's your final answer. And you could have put those answers together and said the 2i is positive, the 2i is negative, plus and minus 2i. You don't have to do that extra work. You do have to show me all of this work. Get used to showing the absolute value, showing the splitting into two parts. That's what you have to show. Next one. It's very similar. We just start by adding and subtracting. It's kind of like the opposite of the order of operations. Normally you end with add, subtract. When you're solving equations, you start. Okay, so take this one. Start by doing some adding or subtracting. I want to pause for a second. And you work on this one. Hopefully you'll come up with an absolute value at some point. And hopefully you can make your absolute value into two equations at some point. All right, I'm going to pause for a second. Okay. Then, square root, and this is where you make the big money in math. Can you handle this? There are people that actually make big money in math. Did you know that? If you're just really good at math and you're like, you know what? I'm really good at math. I'm just going to keep doing this. There's a job for that. It's called being an actuary. And you go to college for actuarial sciences. Basically, it's hardcore math. When you're done with that, you get a job, and your first thing you do in your first few years of the job is take more math tests. Because you just have to get better and better and better at math. And then at the end, you've passed a series of 7 big tests, and then you are a super highly paid person called an actuary. And you could do that if you just want to like have math class for the rest of your life. I know for some of you it sounds like torture of, epic proportion. Like, no, I don't want to do that. But if math is your happy place, you could be an actuary. All you got to do is math classes like this. You're probably going to do it for 10 years from now. But by the time you're done, you pass all those tests, you still got to take review tests to keep yourself fresh. But you just have to be really good at math, and they pay you big money. Yes?
What do you do after you're done? They just pay you big money?
Well, not just to sit there, but your job is you are a person who figures out rates that they should charge for life and health and investment products. So basically you figure out, like lately, for example, the prices of life insurance have gone down. Why do you think the price of life insurance has gone down? People are living longer, exactly. And they have to take all that data, crunch the numbers, and figure out exactly what they should charge for their life insurance policies so that, because why don't they just keep the price high and make lots of money? Because other companies are cutting their rates. They need to know how low can they go and still make a profit. And they have to figure out, based on probabilities and all kinds of other cool math, how much to charge. And that person's job is called actuary. And there's usually one or two of them at a company, and or maybe three or four, but not a huge group of them. But there's a small number of people that make really important decisions about pricing. All right, so you should have absolute value of x plus 2. That's where people screw up. Everybody knows it's 6i, but a lot of people screw up this next part. Then x plus 2 equals 6i. X plus 2 equals negative 6i. Then, if I subtract 2 everywhere, my final answers are x equals negative 2 plus 6i. Now, I could have written that as 6i minus 2, but I chose to write the real part first, right? Negative 2 plus 6i and negative 2 minus 6i. And if you really, really wanted to, you could put it all together into one statement. Negative 2 plus and minus 6i. How many were able to pull that one off? Okay, if you didn't, it's okay. Did you see where you made your mistake? That's the key. All right. I'm going to pause for a second and turn over the reins.
All right, so the recording is back and working again? Yes? All right, so we are going to do one more example together. This one is very similar to the last one we just did, just with a little bit of one extra step that's different from our last one. So I'll give you a little bit of time to try this one out for yourselves. All right, because it looks like a lot of people are finishing up, let's just quickly go over this. So who can tell me the first step that they did? Yes. So you divided both sides here by negative 3. And so on this side, we got x minus 2 quantity squared. What did you get on the right-hand side? All right, negative 16. Someone else tell me what was their next step. Yes.
Put square roots around both sides so you get an absolute value of x minus 2, and then equals.
All right, so we took the square root of both sides. We have our x minus 2 in absolute values. And over here on the right, you said 4i. There we go. All right, someone else, the next step from this side of the room. Yes.
Break it up into x minus 2 equals 4i, x minus 2 equals negative 4.
All right, so we are breaking our absolute value up into our two cases. So we have x minus 2 is equal to 4i, and x minus 2 is equal to negative 4i. And so, if we have this, how are we going to solve for x? Someone from the middle here. Yes.
You would add the 2 up to the side.
All right. And then what did you get from that?
I got 2 plus 4i, 2 minus 4.
All right. 2 plus 4i and 2 minus 4i. All right. And then if we wanted to put these back together as just one common equation, how would we do that? Yes. All right, x equals 2 plus or minus 4i. Awesome. And is that what everybody got? Yes? Awesome. All right, that is our last practice problem for today. So the only thing we have left is we are not doing this one. So we are done, and that is all we have for today.